Yes, same the guy. By the end of this video, we'll be able to name any monocyclic, monoheteroatom, heterocyclic. Please don't forget to subscribe, like the videos, and share. Now, how can we name the monocyclic, monoheteroatom, heterocyclics? One, you need to know the prefix. The prefix, then we form a stem and a suffix. If you know these three, you can answer any monocyclic, monoheteroatom, heterocyclic. The prefix comes from the heteroatoms. Then the stem, sometimes the stem and this one, they are all taken as a suffix. Sometimes the stem is also included in the suffix. So let's see. The prefix comes from the heteroatoms themselves. For example, if you have N nitrogen as the heteroatom, the prefix will be aza. It's aza for nitrogen. If it is oxygen, it will be oxa. For sulfur, this one will be thia. Thia. Then for phosphorus, it is phosphor. Then arsenic, it is asa. It is asa. Then we have terodium as terula. Okay? Terula. Then silicon will be silica. Then we have selenium will be selena. Then we have boron will be bora, and so on. There are many, but most times we encounter these three: N, O, and S. Most times, but there are very many, so they have different names. But this is the prefix. So this one is done. Now this is from heteroatom. Heteroatom. Then the stem, this one tells us the ring size. Tells us the ring size. Now we come here. If you have a three-membered ring heterocyclic, you have a name, it will be iron. Of course, you can't start from one. Ring starts from three. Then four-membered ring will be 8. Then 5 we have, or 6 will be in. Then we have ep for 7. We have oak, then on and egg for the 10-membered heterocyclic. So from the prefix, then you write this, the stem. Then the last part, this one will tell us whether it is the ring is saturated or unsaturated. So it tells us the saturation. It tells us the saturation of the ring. Now we come here. We may have a saturated ring or unsaturated ring containing nitrogen, and those without nitrogen. Without nitrogen meaning that any other heterocyclic compound with no nitrogen. For a three-membered ring atom and it is unsaturated containing nitrogen, will be given ion. This one. So you combine this and this, we form a suffix. You combine the ring size and the saturation, we form a suffix. So it will be irene. Then if it is three-membered and it's unsaturated but does not have nitrogen, it will be in. It's given in. So it will be Irene. We have I here for one containing nitrogen, but this one will be in as a alkene base. Now, we have a 4-membered heteroatom. For the 4-membered and 5-membered and 6-membered containing nitrogen, and they are unsaturated, just add E. Just add E for these ones. Then, for the 4-membered, 5-membered, but they don't have, they are unsaturated, you add E and E. But for this one, for the 6-membered, you don't add anything. You don't add. So, don't add. It will be ending with ine, just for the unsaturated, has no nitrogen. Then, from 7 up to 10, we shall have like the third 4, the one containing nitrogen as heteroatom. Just add ine. Just add this. And here, for sometimes you find that they just add this in. It is either ine or in, but most times this one is preferred for the ones containing nitrogen. Then for those ones which do not contain nitrogen, we add in, and sometimes also add ine. But for them, this one is preferred. It is preferred. Now, when you go to the saturated ones, rings containing the 3, 4, and 5 carbon, if it is saturated and contains no nitrogen, you add N, N, N. But for the one containing nitrogen, we add iodine. Okay. Iodine and iodine. Then for the 6-membered also, we add N. But for this one, if it has no nitrogen, we don't put this stem. From, for example, if it is nitrogen from other, we just add N. Another thing, if you have a vowel here, and you also have a vowel, we drop the one on the prefix. For example, if you have other, then you have N. So we will just write as N. This one is dropped. Also, if it's oxa, we drop this one, then we write only one for the suffix. Then we move for the prefix. So this one, they are a bit special. They are special. So if you write N, we don't put this for the 6-membered and it is saturated, contain no nitrogen. You don't write the stem. And if it is a 6-membered containing no nitrogen and is unsaturated, we don't put E. We just stop at in. Now, for the rest, we just add N, ANE, ANE, ANE. Then here, 6-membered is added ANE. Then 7-membered also add ANE, 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 ANE. But from 7, sometimes just write an AN, AN, AN. Also here, sometimes they just write AN from 7. So this is a summary of how we name the heterocyclics, the monocyclic, monoheteroatom heterocyclics. We are going to use these examples to see whether we can provide the names, the IUPAC names for them. We have this. We said a prefix, if it is containing nitrogen, we say aza. So it is aza. Then we go to stem. It is 5-membered. 5-membered, we have or. And this is a vowel. Also, this is a vowel. So we remove this one. So we write O, then L. Then it is unsaturated. So just add E. So this one is called azo. IUPAC names. We are going to see the common names or the traditional names which are not IUPAC names. But for IUPAC, it is azo. Now we have this one. It is aza, then 5-membered all, but is saturated. Saturated is I, D, N, E. So it is azoridine. Azoridine. We got this one. It has aza, course. Then it is 6-membered. So remove this to be azaine. And it is unsaturated. So it's called azaine. That's the IUPAC name. We got this one. It has oxygen. So we put oxa. It is 7-membered. 7-membered, it's here. The stem is A. So we move A because they are both vowels. So we put E and P. I think. Then from here we go to the suffix. Is it containing? It is containing nitrogen. So it is under this row and under this column. So it is saturated. It's unsaturated here. Unsaturated, we add I-N. So it is oxapine. This one is called oxapine. We have this one. It is oxa, 6-membered with no nitrogen. So we are in this column here. And a stem, we have IN. So it is oxine. Then saturated. So it is oxine. We say that for this one, we don't put IN. So it is oxane. Oxane. Just add A-N-E. You don't put this. We have this one. This one has sulfur, so it is containing no nitrogen. It's under these two columns. One is here, tire. It is tire. Then the stem, it is 6-membered. In, so we remove this A. Put in. And it is saturated. So meaning that this one we shall put we shall not put IN, we shall just put AN. So it is thiene. It is thiene. Then this one, it is other, then it is 6-membered. So remove A, put IN, and since it is 6-membered, we shall add, and it is saturated, we shall add this. So it is as name. It is as name. Now, you have seen how we name the heterocyclics with no any substituents, and they are either saturated or unsaturated. And the bonds are not continuous. So there's a bond, we skip, a bond, we skip. They are not like continuous bonds. Then, in case of partial saturation, or in case they have substituents. For example, this is azo. If it has a substitute here, or here, or here, how can we name it? Now, for that case, if it has a substitute, we add a locant. So it's locant first. Then we go to prefix, stem, and suffix. For example, in case we have here, let me put bromine. For example, we have bromine here. This is position 1. Now, position 2 will follow this, like anti-clockwise, not clockwise, because here you have no substituent, but here you have a substituent. So we follow that position which gives the lowest number to the substituent. Lowest number or locant to the substituent. Locant is the number which shows the position of the substituent. So gives the lowest number or the lowest locant to the substituent. Now this one will be position 1. This will be 2, 3, 4, 5. If this was here, for example, this bromine, if it was here, this one will be position 1, this one 2, this one 3, not 1, 2, 3, 4. You give it the lowest possible locant. So this one will be 2 brom. Then you put this 2 bromo azo, and you put a height 2 bromo azo. If it is this one and you have a substitute here, same thing. This is position 1, 2, 3. In case of maybe chlorine, it will be at position 3, you have 3, so it will be 3. We have chlorine, 3 chloro, 3 chloro azoridine, like that. This one, if it's at this position, you count clockwise. If it's at this position, you count anti-clockwise, such that you give it the lowest possible locant or number to the substituent. Now, in case of partial saturation, as for partial saturation, we have these structures. This one is saturated as this carbon. This one and this one. These ones are saturated. This one is all of it is saturated. Now, how can we name this one? The heteroatom is given the first position. So in n direction, we can name this one. We can number this one. So this one is 1, 2, 3, 4, 5, 6. Or you can number clockwise. The rule is you give the lowest number or locant to the saturated atom. For example, this one, if this one is position 1, position 2 will be this one, the saturated carbon, not this one. We give it the lowest number possible. So it is position 2, 3, 4, 5, 6. Not 1, 2, 3, 4, 5, 6. So it will be like this. This one, if it is position 1, this one will be 2, not this one. Because we want to give the saturated carbons the lowest possible numbers. So this is 2, 3, 4, 5, 6. Now this one is position 1. This one can be 2. No. Because if you give this one 2, this one will be given position 4, the first saturated carbon. Yet, if we count from this side to this direction, this one will be given position 3, the first saturated carbon encountered will be given position 3. So this is 2, 3, 4, 5, 6. Then this one you can name at any direction. Now, if we have only one saturated atom, we use H. So this one will be at position 4, we have saturated carbon, so it will be 4H. Then we give the name for the unsaturated ring, for the unsaturated. So since this one has oxygen, it will be then stem is 6-membered. It's here, 6-membered, but no nitrogen. It's given in. Then for the suffix, we don't add E. We don't add E for the unsaturated with no nitrogen. So it is 4H oxine. This one will be 2H oxine. This one. You give the name for the unsaturated ring, not the saturated ring. This one. We have more than one saturated atoms. These ones, we have position 2, 3, and 4. So it will be 2, 3, 4. Trihydro. Then you give the name for unsaturated ring. Since it is nitrogen, it will be as a trihydro. Then we go to the ring size here, In. Then if it is unsaturated, we just add E. So it is like this, 2, 3, 4 trihydroazine. This one will be 3, 4 dihydro. So if there are 4 tetrahydro like that, so it is dihydro. It is 3, 4 dihydroazine. That is its name. Now, if it is fully saturated, of course, you can give the real name for the saturated compound, or you can say perhydro. Perhydro means that all the atoms are saturated. So it's perhydro. Now we name. But if you use perhydro, you give the name for the unsaturated ring, not for the saturated ring. You can just give it the name for its saturated ring, or if you use perhydro, you give the name for unsaturated ring. So for this case, it will be perhydro so thi, and it is 6-membered. So you don't put this, we just put, okay, we put this because we are using unsaturated name. So thiene, and we don't put E. So it is perhydrothiene. Or you can name it as saturated, which is thiene, if you're using the name for saturated compound or saturated heterocyclic. So that's how we name the monocyclic, monoheteroatom heterocyclics. We have seen the saturated heterocyclics, unsaturated, and you have seen the partial saturated, and you have seen if they have a substituents. Now let's use one example. If it has a substituent, for example, this one at position, this position, for example, it has a bromine. So you just put here, it is position 5, so it is 5 bromo. Then the rest remains the same. That's how we use to name the heterocyclics in case they have one heteroatom and it's a monocyclic. Thanks for watching. Let's go to monocyclic but multi